we are going to do exponents, order of operations, and inequalities. Sorry to hear a bunch of noise. I just flipped my laptop so that I could use it as a tablet. Okay, so exponents. When we talk about exponents, a way that they can be represented is like this. Actually, let's go ahead and do this. Okay, so our x, that is our base. And then our n, that's what we call our exponent. So this would be written in exponential form because it has an exponent. So whenever you see this, what this is actually saying is it wants us to multiply this. Here, let me move this. There we go. This wants us to multiply, sorry, my writing looks funny, multiply our base in times. An example of that, say we have 2 being squared. That's telling us to multiply our base in times. Our base is 2, our n is 2. It wants us to multiply our base 2 times 2. And what we would get is 4. Okay, so let's say if we saw 3 raised to the 4th power. So I know it's going to multiply in times. My base is what's going to multiply in times. My n is 4. So I need to do my base, which is 3, multiplied to itself 3 times. Excuse me. Okay, so that would be 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Okay. Now, if we do this example, which is very, 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 very important, okay? If we see in parentheses a negative number raised to a power, our exponent is also called a power. This is literally saying that we're multiplying this whole thing inside of here by itself, to itself rather, 2 times. So make sure you pay attention to the fact that it's in parentheses. That's literally saying we're multiplying that whole term, the number and the sign by itself. Why do I keep saying that? To itself 2 times. Okay, so using my parentheses, I'm taking my base and I'm multiplying it to itself twice. If you do 5 times 5, you get 25. The signs are the same, so you get a positive 25. Okay, or you can think of it as negative times a negative makes a positive. Okay, the reason why that example is so important is, say it was given to you. I've got kids probably fixing to come inside from playing on their skateboard, so I might have to tell them to be quiet. Say it was given to you just as negative 5 squared. Okay, so if you look at our previous examples, our 2 and our square, all I did was I took the number, right? This, because it involved parentheses, I included the sign. This squared right here, this squared is only on the 5. So what you do is we're actually going to square 5. I wanted to change colors there. We're actually going to square our 5 twice because that's what the exponent's telling us to do to our base. You just can't forget that there's also a negative sign right here. That negative sign is going to go on the outside. So it may look similar to the third example, but watch this. If you do 5 times 5, you get 25. Those signs are the same, so it's positive. But like I said, you can't forget that we have this negative right here in the front. Because there's a negative in the front, you just are going to keep it. Okay, there's not another negative that it's multiplying to change it from being a negative, so it just stays a negative. Okay, so hopefully those examples make some sense to you. Let's go ahead. I'm going to move my screen up. Let's do some order of operations. Okay, so the order of operations, very grade school-ish way of describing it, but it's a surefire way that will always get you to the correct answer. And what it is PEMDAS. Now, what you do is the order that we follow will be parenthesis, exponents, multiplication and division, addition and subtraction. The reason why I wrote those like that is because these are going to follow a rule, basically a rule inside of a rule, right? Like you have to follow the order of operations to solve the problems correctly, but inside of this rule, there's another rule, and it's that my multiplication and subtraction and my addition and, why did I say that? I'm all over the place today. My multiplication and division and my addition and subtraction are going to go left to right. There's going to be some examples and you'll really get to see that like in practice, especially since I just said it all kinds of backwards. Okay, so let's go ahead and do an example. Our first example is 2 plus 8 minus 2 squared. Okay, so following the order of operations, I know that I need to look to see if there's any parentheses, and there's not. That Coke was for dinner. That Coke wasn't for right now. Just so y'all know. It's probably not cold yet. We don't have any parentheses, so we're going to look to see, do we have exponents? And we do have exponents. Right here. That 2 is being squared. So I'm going to write my whole problem, and I'm just going to evaluate each individual thing, okay? So I'm going to do it on the right-hand side and right horizontally, okay? We have 2 plus 8. Then if you look, that 2 is being squared, which is a 4, and then you have that negative sign. So we have a negative 4. And now using our addition, subtraction left to right, what we're going to do is add the 2 and the 8, which gives us 10, and then we have a negative 4. Well, 10 minus 4 is 6. Okay, so I'm going to slide up. If y'all want to write the order of operations down somewhere, that way you have it and you can refer to it, okay? So for the second example, we have 7 plus 5 times 6. Order of operations, there's no parentheses, there's no exponents. Next is multiplication and division. There is multiplication and division. And it's actually going to be right here. So what we have is 7. And then if you look at your 5 times 6, you get 30. Those signs are the same, so it's a positive 30. And then we're just going to add straight across. You do 7 plus 30, you'll get 37. Okay, so our third example is 21 minus 3 times, erase the whole thing, 3 times 3 plus 9. Just a word of advice. I'm pretty sure I said this in the fraction video, but you want to make sure that you don't use an X for multiplication. You want to actually use a dot, because whenever we get into our variables, which will be, I believe the next section, we'll be using an X to represent those variables, and it could just get really messy, okay? So order of operations, you do multiplication first. Rewriting this problem, I have 21, and now what? Well, I have 3 times 3, which is 9. Those signs are different, so it's a negative 9, and then I have a plus 9. Okay, and then if you look right here, we need to make sure we go left to right, okay, with our addition and subtraction. So this is the first subtraction that I see. And if I do 21 minus 9, I get 12 plus 9. And then here, 12 plus 9 is 21. A lot of people will see that this looks like it makes the most sense and you want to just make them go away. In this answer, which is really weird the way it worked out this way, probably wouldn't have steered you down the wrong path. You just really need to make sure that you go left to right, okay? Just kidding. Example 4. 60 divided by 3 times 4. I'm going to do the division first. 60 divided by 3 is 20 times 4. 20 times 4 is 80. Good? Oh, sorry. And 20 times 4 is 80. Okay, now let's do this example right here, which is 52 plus 36 divided by 6 times 8. So order of operations, multiplication and division, you do left to right. That's the first multiplication or division that I get. So I have 52. Okay, so 36 divided by 6 is 6. Signs are the same, so it's positive. And then don't forget our times 8 over here at the end. Okay, so again, with the multiplication, I have 52. 6 times 8 is 48. Signs are the same, so it's positive. If you add those together, you get 100. Okay, so let's do these 3 other examples, and then what did I call this video? I'm going to go ahead. Well, I'm going to take off inequalities. We're just going to make this exponents, order of operations, just time-wise. I don't ever want there to be a video for y'all to watch that's too long or anything. Okay, let's do these last 3 examples. Okay, say we have 3 in parentheses, 5 plus 4, close parentheses, plus 8 times 5. Whole bunch of stuff going on there. But I know I have an actual order, process that I have to follow. And if I do so, the first letter in my order of operations is P, which is parentheses. I have parentheses here. Okay, so what you do is you compute what's in those parentheses. You evaluate what's in those parentheses. You solve what's going on inside of those parentheses. Okay, so we would have 3 in parentheses. If you look at 5 plus 4, you get 9. Close parentheses, we have a plus 8 and a times 5. I'm going to work down. Okay, kids. Why did I say kids? I'm so used to all my children running around calling them kids. So if we look here, order of operations, multiplication would be the next thing that we use, and we're going to go left to right. So what we would do is the 3 times 9 first, which would give me 27. Then we have plus 8 times 5 equals 27 plus 8 times 5 is 40. And what I get here when I add those together is 67. Good? Okay. Almost done, y'all. Say we have 36 minus 5 squared plus 9. Okay, so if we do this order of operations, I notice my exponent. I have 36, 5 times 5 is 25. Don't forget the fact that you did have that negative there. Hey, this is not negative 5 times negative 5. This is 5 times 5, and then you have that operation sign right here. And the reason why I know it's not a negative with each 5 is because it's not in parentheses, okay? And then we have plus 9. So if you look, I just have addition and subtraction left. If you do 36 minus 25, you get 11. plus 9 equals 20. Okay, last example. This is an example just to show you how you could see a whole bunch of different signage going on, and you could see a whole bunch of different kind of like symbols or notation that you might not be used to seeing. And that's technically the fact that parentheses and brackets act as the same thing. So let me write this out real quick. Okay, so here we have 4 plus 2 in brackets, 3 plus 2 in parentheses, 3, close parenthesis, close bracket. So what you want to do, order of operations, are your parentheses first. Well, I've got 2 sets of parentheses, I think, and that's right, you do. But as far as notation is concerned, if you ever have a set of parentheses and you need to enclose it again, and you need to enclose it again, or you need to enclose it again, do you see how it kind of alternates? They do that just to make things a little bit more clear. You're always going to work from the inside out, and having them in parentheses and brackets and having them alternate, it's a lot easier to figure out, okay, which one's inside of the one that's inside of this one, and to just really be able to locate, where do I start? Okay. So where I would start would be here. I'm going to work down on this problem since I've done that right there, okay? So I have 4 plus 2 bracket 3. Now look, 2 times 3 is 6. Signs are the same, so it's positive. And then if you go to the right here, I have my parentheses still, right? Like, I mean, technically they're brackets, doesn't matter. Because there's only now one set of something, you can just start writing them as parentheses. I have 4 plus 2, that's going to be a times 3 plus 6 is 9. Okay, so we have 4 plus 2 times 9. Well, of course, I'm going to do the multiplication first, right? This right here. And so what I would get is 4 plus 18, which is 22. Okay, and there you go. Thank y'all. Bye.